The screen is visible?
Yes, sir. Screen is
Yes, sir.
visible. Is it comfortable, sir, to start the session
Just
now?
1 minute. Just 1 minute.
Okay, sir.
Yeah. Yes. Yes, madam.
Okay. Thank you, sir. Good afternoon, everyone. I am Dipali Chatrikar from ENTC department. Welcome you all in the session 12 of our FDP, AI and its application. It is my honor to introduce our speaker of session 12, Dr. Bhagvat Jadhav, sir. Dr. Bhagvat Jadhav, sir, is a distinguished academician and researcher with the over 22 years of experience in the field of electronics and telecommunication engineering. Dr. Jadhav sir has an impressive academic background, including PhD in Electronics and Telecommunication from Savitribai Phule Pune University. His research on high-resolution multispectral satellite images for land coverage mapping and agricultural management is a testament to his commitment to advancing knowledge in the fields of IoT, AI, and ML. He is not only an accomplished researcher but also an innovator with several patents to his credit, including systems for urban settlement monitoring and automated vehicle detection. Currently, Dr. Jadhav sir is working as a controller of examination and professor in ENTC at JSPM Rajshri College of Engineering, Pune. Dr. Jadhav sir is a member of Board of Studies in Electronics and Telecommunication Engineering Board at Savitribai Phule Pune University. He is recognized a research guide at Savitribai Phule Pune University. Currently, he is mentoring 4 PhD scholars in the area of satellite image processing and electronic devices. He has authored over a 50 plus research articles in the peer-reviewed journals, international conferences, and book chapters. He is an active member of ISTE, IETE, and IEEE. Dr. Jadhav sir has held numerous leadership roles such as Chairman BOS ENTC in rscoe Autonomous College, Controller of Examiner for Autonomous Institute, Examination Coordinator in SPPU for UG and PG Online Examination, College Examination Officer for Savitribai Phule Pune University.
Madam,
Chair-
thank you very much. Just
Okay,
conclude.
sir. Okay, sir. Okay, let us give a warm welcome to Dr. Bhagvat Jadhav sir as he enlightens us on the CNN topic. Thank you, sir. Sorry, welcome, sir. Now I'm giving the control of session to you.
Yes. So, good afternoon to one and all. Am I audible?
Yes, sir.
Sir.
Yeah. So, good afternoon to all the participants, my dear colleagues, and the faculty members of the JSPM's Rajarshi Shah College of Engineering. Thank you very much, Dipali madam, for the nice introduction. Today, I'm going to talk on the convolution neural networks, that is the CNN. Basically, before the CNN, we have to talk about what is a machine learning, what is a AI, what is a deep learning, and all these basic aspects we are going to talk. So in my presentation, I'm going to cover the different aspects. So the contents of my presentations are introduction of neural networks, architecture of the neural networks, ANN, that is artificial neural networks algorithms, forward and the backward propagation, which is an essential part of the ANN. What are the limitations of the ANN? And to overcome that limitations, we are going for the CNN, that is a convolution neural networks. Case studies of the ANN, case studies of the CNN, and the practical session, I will try to show the some 2 case studies in the ANN as well as the CNN. My dear friends, basically if you want to learn the CNN architecture or the detail in the CNN, we should know the basically ANN, that is artificial neural networks. What is a neural networks? How this neural networks is working? What is its basic fundamental concepts? How they are connected to each others? How they are calculating their accuracies and all these aspects. If you want to learn from the CNN, then we have to go for the basic fundamentals. As I know the message from the department's coordinator, Bisikar madam, there is a mixing of the participant, experts, as well as some newcomers are also there and new researchers are there. They want to do the research in this field. Am I right? So with taking this particular cognizance, I'm going to talk about the basic fundamentals. My friends, I'm also from the electronics department background, but since 1 year, I'm going to try to get the more insight in the artificial intelligence and the machine learning. Recently, I completed the 6-month AICTE PG certification course on the AI and ML at IIIT Lucknow. So there was, we conducted the professors from the IIIT Lucknow conducted the sessions for us, complete 4 months in the online session every day at the evening. And I physically went there at the IIIT Lucknow and I stayed there for the 1 month. That is for 15 days in the first part, second part in the 15 days. And the detail about the basic fundamentals, what we can see for the different application, which is required in the ANN, CNN, deep learnings on all the fundamental aspects I try to learn. Whatever I learned there that I can put in front of you. So I'm also learning the new things. As a teacher, learning will not be stopped and we should be always in the learning modes. So coming to the topic, as we know the artificial intelligence, our particular workshop is based on the ATAL workshop is based on the AI in the research. How this artificial intelligence can be used in the research. So as we from the diagram, the artificial intelligence is a bigger area, that is a broad area. And inside the artificial intelligence, there is a machine learning, and inside that machine learning, there is a deep learning. So we can see that there is a autonomous car. Autonomous car or the driverless car is nothing but the complete artificial intelligence applications. But whatever the algorithms they use for the training that particular machines, training for that particular hardwares is nothing but the machine learnings. And inside that machine learnings, and there are some agents are there are some environments are there, and a lot of things are there. If you consider the artificial intelligence is a big and vast area, taking the buzzwords as a artificial intelligence is very simple, but if you see the details, there is a lot of complexities are available. So how this AI can be refers? The AI is refers to the simulation of human intelligence by computer system or machines. It involves designing the algorithms and models that enable machine to perform tasks typically requiring the human intelligence. So Alexa, you might be known as Alexa. What is Alexa? Alexa is a intercommunication between that is in our car is there. So these are the real-time application of artificial intelligence that we are using day-to-day applications. And most of the researchers or the experts from the first day, they talked a lot of things. Now, in this artificial intelligence, machine learning is playing the important role. And there are the machine learning techniques are there, which are the unsupervised machine learning, supervised machine learning, and reinforcement learnings. So basically, difference between these all is known to, it might be known to us. Unsupervised learning, machine learnings are related to the non-labeled data. Non-labeled data is nothing but, so there is no expected outcome, they don't know, unlabeled data. And the supervised machine learning, that is labeled data. What do you mean by labeled data? So whatever the data which is available from that labeled data, we have to make the categories. Suppose I want to make the classification of the brain tumor. So whatever the database, whatever the images are available, from that images, I can classify whether that particular image is a tumor, that is the brain tumor is there or not. So yes or no, that classification zeros and ones. Particular person is having the tumor or not. So that is label data. Then third category comes as a reinforcement learning. That is nothing but the learning through the experience. So agent or the machine itself is going to learn their experiences, and the rewards and the actions are there based on the particular rewards. On the basis of the rewards, the action will be taken by the machine once again. So that is automotive robots are there, cobots are there. These are the best example of the reinforcement learning. In between, if you go to the depth of this machine learning, then is a subset of the machine learning, that is a deep learning, that focus on the algorithms inspired by the structure and function of the human brain, which is known as artificial neural networks. So the deep learning, in the deep learning, artificial neural networks is playing the important roles. And this artificial neural networks has the other categories, that is ANN, CNN, RN. So we are going to focus much more on the deep learning concepts of in the today's session. So what is a neural networks? It is a computational model inspired by the structure and functioning of the human brain. So it is a correlate to the human brain. It consists of the interconnected layers of nodes, which is called as the neurons. Nodes are called as the neurons, and that process the data and extract the pattern to perform tasks such as classification, prediction, or the decision making. So all of you know, this is one of the figure. What we can see, this is what we can say the internal structure of our human brains, and these are the different aspects of the brains are there. How there are different neurons in our brains, and they are interconnected to each others. The specific neurons are fires, and the decision will be taken by that particular situation. So as we know, there are the two minds in every humans. May I do this or do not this? The majority of the thinking or the neurons comes in the positive direction. Then you can taking the decision on that particular aspects. So there are the n number of neurons are there. They are interconnected to each others, and from the collective efforts, they will take the decision for that particular aspects. So whatever the deep learnings also playing the important role with respect to these neurons. So if you want to see the complete architecture of this artificial neural networks, that is a neural networks, input layers are there, hidden layers are there, output layers are there. So this each node is acting as a neuron here. Neurons are nothing but each node is acting as a neuron in the artificial neural networks. So the internal hidden layers are there, H1, H2, H3, and they are interconnected to each others. At the output side, here the outputs are the 1, 2, 3, and n number of outputs are there. So from that network, if you want to get the results in the discrete mode means yes or no. Yes or no means the image is brain tumor or not tumor. Yes or no, that is a binary classification is there. If you have the multiple class, so multiple class are there. For example, we can say the classification of the fruits, classification of a disease, any other disease. So n number of images are there. We can have the disease classification. Then we have the multiple outputs are there. Multiple label data are there required there. So depending upon your input data, depending upon your applications, we have to design these architectures in terms of the multiple outputs or the binary outputs. Binary means yes or no condition, and multiple outputs are nothing but we can have the different classifications can be done on the basis of this particular networks. So which are the important elements are present in that I will show the details. Weights and biases are there. Weights are present there. Activation functions are there. Loss functions will be there. Optimization layers are there. And back propagation concept is there. So we have to remember all these basic elements in any artificial neural networks or the CNN architectures. So let us will see what is exactly this particular weight function, what is a bias, and what is a activation function. We can see activation functions, and then further loss functions will be represented. then optimizers are there, and all these things are there. So we can see this is one of the neuron. This is one neuron. So for these neurons, these are the different inputs are there. So let us say this neuron, this is acting as a one node. This is one node is equal to one neuron. For this one neurons, there are the n number of inputs are there, x of I0 to the x of ID. These are the inputs are there. For this each input, we are connected some weight. Weight and the biases are the playing the important role. So weight is there, and for this weight, we can add the one more bias is there. It is not shown here, but the here one bias is added, one more here, one bias is added here. That is a B0 or the some T constant bias is there. So this bias is added there. After this, we'll get this. What is the summation of this particular? We'll get the summation. What is the summation of this? X of 0 into W, x of I0 into W0 weight. Second input, their weights. Third input and their weights. So this becomes as a, what we can say, the input, and plus bias will be added there. After this bias, the results will be going to the further. That is nothing but the, what we can say, the activation functions. What we can say, this is the activation functions are there. So we can use the different types of activation functions. I will discuss in the more details in the next slides. So if you hear there, we can see the once again, input vector is there. Vector is nothing but the input data. Weight vector W is there. Weighted sum is there. And we can see this is your bias. The bias is present here. And the activation functions are here to get the results in the output results. So for example, Y output of this one neuron or the one perceptron, we can see, sorry, perceptron. What is the output of this one perceptron? Sigmoid. Sigmoid is one of the function is used. So here the sigmoid function is used. That is activation function. Why sigmoid function is used? What are the different types of functions are there? That we will see the little bit later on. And what is the summation? Summation of this input into the weight factor plus the bias. So the n-dimensional input vector x is mapped into the variable y by means of the scalar product and non-linear functioning mappings are there. So this activation function is a non-linear functions. Now how this perceptron, that is, this is the one perceptron is there. How this perceptron is working? Basic unit is a neural networks. Linear separator is there. Parts are the inputs. Weights are there. Bias. Input is there, x of 0 constant, and associated weights is a W0. Weighted sum of the input, y is equal to omega 0 x and etc. etc. A threshold function or the activation functions are used to create the non-linear results. So if y is greater than 1, y is greater than t, then the output will be 1. The y is less than t, then the output will be the -1. So these activation functions are used to convert into the non-linearity of that particular function. That is in terms of the yes and no concept for the outputs. Then further, if you see the detail once again in details, that is a ANN model is an assembly interconnected nodes and all these things are so. It is a similarly we can understand what is this single one ANN perceptron. We can understand this. That is with respect to the nodes. Then how they are connected to each others. So that they are connected to each others by the two ways. One is a feed forward networks and recurrent networks is there. So what is a feed forward networks? That is input unit is there, hidden unit is there, and output unit is there, and they are forwarding that particular networks. Input is a feed forwarded from the input side. So this competes a series of transformation. Typically, the first layer is the input layer, last layer is output layer. Now, second thing is that is recurrent network is also there. These have the director cycles in their connection graphs. So director cycles in their connection graph, they can have the complicated dynamics, more biological realistics is there. So this is a little bit complex as compared with the feed forward networks is there. Then we can see in this particular here, what we can see, this is a multi-layer feed forward networks is shown to here. One or more layers input, and we can have the multiple output layers are there. what we can say, this is a multiple outputs are there. Now, how these ANN algorithms can be work? It initialize the weights. First, the random weights are allocated for this each and every allotted the inputs. Adjust the weight in such a way that the output of ANN is consistent with class label of training examples. That is error function. So we are ultimately we have to make the error 0. So basically in the deep learnings we have to train the model first, then we have to test the models. How can we train the models? We have to train the models based on the input data. So whatever the input data are available with us, that we have to divide into the training data set and the testing data set. On the base of training data set, there are the label data are there. So we can understand if there are the 10 features are there. Based on the 10 features, output is results is a high. That is a high. Brain tumor is there, or the we can say the iris based data is there. That is a iris database there. Classification result is high. So label data are there. Based on the label data, we train the models. And while training the models, what we have to expect there, that error function should be as minimum possible. The probability of the error should be 0. Probability of the error should be 0. So error function has to be become 0. So first of all, our algorithm will be calculated the forward propagation is there. Forward propagation means for each inputs, they will calculate the sigma. After that sigma, will provide the activation function and check the results. If the actual results and the predicted results is a difference, there is a error, then whatever the error is available for that error, your weight functions are once again reverse calculation. So find the weights wi that minimize the above error. So these weight functions are continuously adjusted, or that is a varied based on the your error difference of the actual output and the predicted output. So for each iteration, the predicted output and the actual output will be differentiated. If the error is more, once again the weight is adjusted, weight is recalculated, and once again go to the forward propagation. So forward propagations and backward propagations are playing the combinations and to get the desired results to reduce the error. So for this, to find out the weight, respective weights, the gradient descent and back propagation algorithms are used in this particular concept. So gradient descent and the back propagation algorithms are used to reduce to adjust the weight, and by adjusting the weight, we can reduce the error. As we reduce the error, then we can say that our algorithm or our machine has been trained. Once the machine is trained, we can test the machine. So that is a fundamental concepts in the artificial neural networks. Let us will see what is a gradient descent. Now, this is once again mathematical concepts of the gradient descent. We have to maximize the concave function, minimize the convex function. So if you know about the little bit more mathematics, they can understand. But my main concept of the understanding is like that we have to make the differentiation. To reduce the error, differentiation has to be there. So differentiation of the expected results or expected, that is a differentiation of the output with respect to the expected results. And so delta W is nothing but the change in the weight function. So this change in the weight function is mapped with the eta delta WL. So this eta is nothing but the learning rate. So it is called as a learning rate. And this learning rate is between the 0 to 1. Learning rate is having the value of the 0 to 1. So what should be my learning rate? So by default in our programs, learning rate is adjusted by the algorithms. You can vary this learning rate. So we can say the parameters. One of the parameters for getting the results in different ways, nothing but learning rates. The value of the learning rates varies from 0 to 1. If I keep the learning rate maximum, what happens? If I get the learning rate minimum, then what happens? These two concepts we can understand, and these analyses are there with respect to the learning rates. Now, suppose we have the scalar function f of w. F of w is nothing but weight function. So this weight function has to be calculated once again. We want to find out the local minima. Local minima is nothing but the difference between the expected results and the output results should be 0. That is ideally 0. So to find out the difference minimum, we are going further to find out the local minima. Assume our current weight is W. Assume our current weight is a capital W. So this function capital W. So we are going to derive it. We are going to derive this function FW with respect to capital W. Then we'll get the new W multiplication of the that is a learning rate, and this will be converted into the change in the W, that is a gradient descent rules, and this change in the W will be applied for the further functions. Now once again this change in the W or the delta W, it is once again matrix, because we have the n number of inputs. For that n number of inputs, we having the W is a matrix once again. So each and every time the weights are adjusted till I'm getting the predicted outputs, and the actual output is minimum. That is difference between should be minimum, and it's nothing but the error is minimum. Till that we have to adjust. So these are the some linear perceptron training rules are there, and the standard algorithms are available in the many researchers books or researchers articles, as well as the many books. So I will not talk much more about this mathematical aspects. The batch perceptron is there. Randomly, what is process is there? Randomly initialize the weight W1, W2, W3. Get your database, apply to once. That is once to the input. So first layer we have to apply the database. Then if I is equal to 1 to R, that is what we can say that there is variables. We have to adjust the get the results, adjust the weights. If sigma delta I stops the involving the then stops, improving then stop. So if the error is not increasing more, error is not decreasing further and further. If you have done the n number of iterations, after the n number of iterations, still also error is not getting the decrease, then you have to stop that particular process, stop that back to the 3, and we have to say the algorithm or the your machine has been trained. So that algorithms are there that I can show in the your practical aspects also. So what we can see the mathematical model, there are in this layer, there are the 2 inputs are there, and 3 hidden layers are there, and 1 output is there. 1 output is there. So either 0 or 1, output will be zeros and ones. So x1 is my input, x2 is my output. How these nodes or perceptrons are connected to each other, that you can understand. W11 is a weight for the input 1 and going to the hidden layer 1. W21 is nothing but the weights is connected from the to the node 2, hidden node 2 with the input node 1. Same thing here, the hidden node 3, that is hidden layer 3, layer 3, and we are connecting from the input. So weight becomes W31, and like that, having the, this is also once again called as a perceptron. They are working, that is a summation of all these things. Then we apply the activation functions. Then output is there and connected here further. So each what we can say in perceptron work in the that particular actions, and we are getting the results at the outputs. Now, as per the what we can say here, we understood the basic elements. So weight functions are there, activation functions are there, loss functions are there. So we can understand what is a loss function here. So we are adding the here dropout layers are there. So if the network is very input data is very high, then we added the hidden layers, we added the input layers, we added the output layers, and there is a mesh of networks is created, and the computational complexity is increases. It is having the more number of inputs are there, more the internal neurons are connected to each perceptrons are connected to each others, and it will create the very high level of the computational complexity, and the whatever the your model is overtrained. Once the model is overtrained, then the accuracy is going to reduce, the error is going to increase, and that's why to reduce the size of your matrix, size of the models, size of the networks, we are going to drop out the few layers in between that, and that's for the epochs 1, epochs 2. Based on that particular, we can reduce the some dropout the some layers to increase the computational complexity and the reducing the size of the particular networks. sorry. In the activation functions, so what is activation function and why we require? Learning of the complex and non-linear mapping, we require the activation function. It gives the ability to model real-world complex data effectively by introducing the non-linearity. So non-linearity is going to introduce to the activation function. It enables the selective neuron activation. So whatever the neurons, selected neurons, we can make the activate by using this activation function. Without activation function, neural networks should lose their power and personality. So we are adding some activation functions are there. So which are the different types of activation functions are there? The first is a sigmoid. Output values is between zeros and ones. Output value is between the zeros and making it suitable for binary classification. So sigmoid function is a very suitable for the binary classification. Tan is output values from -1 and +1. This is one more type of the activation function. ReLU is a rectified linear units, output values from the zeros and infinity. So ReLU function is this is, so output values are from zeros and ones. One more having the softmax is used for in the output layer of the classification networks to produce the probability of the distribution over the classes. Probability, what is if there is a multiple outputs are there, multiple what we can say the output we have to binary, multiple classifications are there, then we can go for the softmax function. So that will be the distribution of over the different classes we can understand by using this activation function. So the activation functions are playing the important role to make the classification precisely based on their what type of activation functions we are going to select in their results. As we are seeing we are using this is a fundamental particular concept of the ANN, and there are some limitation of the ANN, and that's why we have to shift from the ANN to the CNN. So what are the limitation of the ANN? So I think all of you understood the basic architecture of the ANN. Am I right?
Yes, sir.
Participants, which are the different layers are available that we can understand in the ANN? These are the basic neurons, layers, weight and biases are there, activation functions are there, loss functions are there, and optimizations are there. Which optimizers are there, that I will discuss later bit. And to achieve these results, we are going for the back propagation techniques are there to reduce the error. So I will show you in the practical also that will try to understand precisely. Okay. Now coming to the next point, whatever the limitation of the ANN that can be overcome in the CNN, and that's why you have to learn the CNN. So CNN is a basic further expansion or the extension of the ANN, artificial neural networks. So what are the limitations? High number of parameters are there in the ANN. To reduce that parameters, the CNN can be used via shared weightage and the sparse connectivity. So sparse connectivity and the weightage can be shared. That can be done through the CNN. So whatever the limitation of ANN, that can be overcome. Lack of spatial feature extraction. So the ANN is used for the tabular data. ANN is used for the tabular data. Excel data are going to use for the ANN. That is one-dimensional data, which is having their application where the one-dimensional that will be used for the ANN only. But if you have the classification in terms of the image, if you say the image we are going to convert into the two-dimensional data. These are the pixels, and based on the two-dimensional data is not going to work for the ANN. Then we have to go for the CNN. Uses convolution to extract the spatial arrays and the features. So edges, textures, object detections, and all other things. If there is a data are the two-dimensional data, images are there, then we have to go for the CNN. Inefficiency with image data, just I discussed with you. Overfitting risk are there. And this overfitting risk are there means overfitting the model means what? If the learning rate is different, then weight functions are there, then input data is very high, then the overfitting of that model may take place. And to reduce the overfitting by using the fewer parameters and employing the dropout or data augmentations. So data augmentations or the dropout layer is there. that will be there used for the CNN. Then manual feature extraction is required in the ANN techniques. Manually, we have to extract the features, but in the CNN, it performs automatically. Feature extraction of the is going to take place through the CNN. Sensitivity to the transformations in the ANN. So transformation means what the image that is SIFT, resizing the image or resizing the data or other things are there. So learns invariant features through the pooling and the localizing filters. So there are the two concepts are there. Pooling is there. That is a we'll try to understand what is the pooling. Pooling layers are there that will be converted the one-dimensional data into the two-dimensional. That is two-dimensional data into the one-dimensional data is there, and localization filters are used in the particular CNN. So whatever the limitation of the ANN that will be overcome in the CNN, and that's why we are going for the CNN. For example, we can see the detailed architectures with some example. So this is one of the recognition of pattern. The input image pattern is given. So there are the edges and boundaries are there. For the any image, there is the edges and the boundaries are there. Now, what is the first stage is going to take place? That will be see the straight lines. We can understand that is a tilted lines, straight line, vertical lines that will be identified by the first stage. What does the second stage? Second stage will be trying to understand the edges. That will be recognize the edges. Then third stage, what will be there? They will be combining the two stages, edges, and that will be converted as a hub part of the image recognition, which is at the input pattern. Then in the fourth stage, we can connect these third two stages, and I can get the recognition of the complete patterns. So the neural networks or convolution neural networks are working connectedly to recognize the particular image. Connectedly to recognize the particular image. So edges first will be identify the edges, then further features, and then will be they connecting to each others and get the final recognition of that particular image. So this is a basic architecture that will be helpful to understand how this CNN can be work. Then we can have the latest architecture. We can see convolution neural network. We have seen the architecture of the ANN. Now we are going for the CNN. So input is there, convolution is there. What is a convolution? So in the frequency domain, input signal and the output signal, they are multiplied. But in the spatial domain, they are making the convolution. Spatial domain in the sense pixel domains. The pooling layer is there. Pooling layer is converting the two-dimensional data into the one-dimensional data. So whatever we can see, understand this particular part is once again fully connected network. And this fully connected network is nothing but ANN. Fully connected network is ANN, that what we understood earlier. And then we are going to classify class A, class B, class C. But before these fully connected networks, whatever these things are available, this is nothing but the complete part of the CNN. So why it is called CNN? Convolution neural networks. Convolution. So convolution is going to take place with the input and your filters. We are applying some different filters, and that different filters are making the convolution to the input layer, input data, and then pooling is going to take place. So this converts the two-dimensional data into one-dimensional data, and then we'll be converting the results. So as we know, ANN is going to classify only the one-dimensional data, but the images having the two-dimensional data, and the pooling networks will be converting this particular two-dimensional data into the one-dimensional data in the part of the classification of the architecture. So this is a basic architecture of the CNN can be present. Now, heart of this neural network is a convolution process. Convolution. So what is meaning of convolution? As we can see, this is my image. So what is the image size? This, let us say this is my image size. And for that image size, 6x6 matrix is there. 6x6 matrix is there. And we are applying this filter as a convolution filter. So what is a filter? Filter size a 3x3 matrix is a filter size. And this filter is going to make the convolution on this particular 3x3 size of the image. So total size of the image is 6x6. I will take the first left-hand side of the 3x3 matrix. On this 3x3 matrix, we are making the convolution with this filter. So this filter is going to mask on this 3x3 size of the input image out of 6x6. So what is the resultant thing will be there? So if I made the 3 into see what we can do here, filtering operation, that is nothing but multiplication and dividing. So how many matrices are there? 3x3 is nothing but the 3 into 3, 9 is here. 1 by 9 in bracket 3 plus 1 plus 0 plus 1, then 1 plus minus 1 and so on. So we have to make the convolution. So matrix multiplication will be done. That is a individual matrix, that is 1 to 1, 0 to 0, divided by summation of this, we'll get the minus 5 here. Then we'll select this next 3 parts, next 3 by 3, once again make convol, get the results, then so on. So complete convolution process will be done. As is there is a 3x3 image. This is a 3x3 image, and for the this is a color image. For the color image, we have the RGB are there. So R, G, and B. These are the 3 filters we have to make. 3 filters, 3 times multiplication convolution has to be done, and we'll get the 4x4 matrix networks. Matrix will be represented at this, and we'll further apply there. So then next we are using the pooling layer. So pooling layers are nothing but the max pooling can be used. So function of pooling is to progressively reduce the spatial size of the representation to reduce the amount of the parameters and competition in the networks. So what we can see here, now we can understand this is my output of the convolution. This is output of the convolution. In the output of convolution, we have this particular 2 by 2 networks. 1, 4, 1, 8, these are the pixel values of this 2 by 2 matrix. And we are applying the max pooling. So one of the example of max pooling layer, F is a 2, S is equal to 2. So this is a 4 by 4, this is a 4 by 4, this is a 4 by 4 matrix that will be converted in the 2 by 2 matrix. What is the purpose of this? It will be reduce the spatial size, means dimension of the matrix is reduces, and amount of the parameters or computational complexity will be increased. And this is a max pooling. So out of this 1, 4, 1, 8, which is max 8, that will be putting here. What is the second here? Once again, here is a 6, 3, 9, 7. So what is the max? Here is a 9. Then further, if you see this one, that is a 2. This particular thing is a 9 is maximum that we can put here. Then this is a 1 more. This can be 4. So we have converted this 4 by 4 matrix into the 2 by 2 matrix, and this max pooling is used. So ultimately, we are going for the pooling networks. We are going for the fully connected networks, and further classification is going to take place. As we understand in the initial stage, the deep learning can be classified into the 3 parts. One is the ANN, CNN, RCNN. So ANN is for the data which is represented in the one-dimensional. Application of ANN is for the regression analysis, prediction in the tabular data in terms of the Excel data, and classification based on the data which is available in the tabular format. CNN is used for the image classification, that is used for the recognitions for the 2-dimensional images. Then we can say the classification in different application objects and etc. etc. RCNN is nothing but the recurrent neural networks designed for the sequential and time series data, capturing the temporal dependencies. So natural language processing, NLP, that is a natural language processing, speech processing, that is a continuous data. They are recurrent data, and for that recurrent data, continuous data, we can use this RNN network. So capture the temporal relationship between the sequence and data predictions. So typical example of the RCNN is nothing but the prediction. Suppose we are having the artificial intelligence in the what we can say the online shopping websites are there. We can say the Zomato is there, or we can say the any another networks are there. So if you have selected in the online that is purchasing websites are there, or the network systems are there. If you are purchasing for the, let us say, the mobile, automatically they will give the some pop-ups related to headphones. So they will identify the what is the intention of that particular users, and automatically they can get the next for the recurrent. So this recurrent neural networks are the playing the role for the temporal data, and the recurrences are there, and all these things are there. So CNN for the image classification, RNN for the temporal data, NLPs, ANN is for the simple one-dimensional data, and the classification for the Excel-based data. So these are the classifications or differentiate. I will not discuss much more, but how can we differentiate? Once again, use cases of ANN, CNN, and RNN. Image classification, ANN cannot be used, CNN is used, RNN is not used. Text classification is there, ANN can be used, RNN can be used, but the text can be converted into the binary digits. That is for the tokenized purpose in the ANN, and then ANN can be used for the text classification. But further, for the huge data and the recurring data is there, text classification, we can go for the RNN. Time series forecasting is there, that is future predictions are there in terms of the time series. Then you have to go for the RNN. Speech recognition, that is a CNN with the spectrogram. Spectrograms is there. Then we can go for the, that is a, in terms of the images, spectrograms are there. Then you can go for the CNN. Otherwise, we have to go for the RNN. Video analysis, for temporal analysis, RNN is there. But if it is a spatial analysis, only the spatial analysis there, then you can go for the CNN. Tabular data analysis in terms of the Excel, ANN is sufficient. Object detection, CNN, and the machine translation, that is nothing but the natural language processing, NLP, speech recognition, and all these things, that is NLP, machine translation. That is any language from the Marathi to English, English to Hindi, or Hindi to any Urdu, and all these things. Then we have to go for the RNN networks, which is a highly recommended. So this is a basic things we can understand which type of the networks can be used when or based on the applications. So this is a different use cases are there. Now, as I have discussed the details about the concept of the ANN, CNN, and the little bit idea about the RNN. Now I will give the one case study, detailed case study of the my part of the research. One of my research students are working in this particular area. That is nothing but detection and classification of pomegranate fruit disease using the convolutional neural networks. Dear participants, are you with me? Yes or no? Madam?
Yes, sir.
Can I go for the next? So this is a detailed architecture I explained. Now I will go for the one of the case study, and then I will go show the some practicals, how this implementation can be done, which are the performance parameters has to be calculated as the researchers. Am I right? Okay. So the case study for the one of my research student that is working on this particular domain, that is a detection and classification of pomegranate food disease using the CNN, that is a neural networks. Now this CNN is a basic network. There are the further VGene 69, all other further high-end networks are available that you can study later on. But this is a basic networks. We know the agriculture is one of the kind of source of wealth and develop the farmers. All these things are there. Now pomegranates have the different diseases. So what are the different diseases are present in the pomegranates? We can see these are the different diseases based on this. We can see this is one of the disease, and that is called as alternaria. These are the fungus that causes dark spot on the plant parts and the roots, generally known as a black spot and hurt root. So this is a image of the pomegranate, and that goes the classification of alternaria disease. Second is a Cereopora, that is a symptoms, which is here is once again black dot, which is on the leaf, and there are some black dots are present on the fruit. So the images which comes in this particular categories are having this second disease. Third type of the images is nothing but a anthraconus, that is symptoms. There is a small regular or irregular black or brown colored spots are available on the leaves, stems, flowers, fruits, which turn later on the dark brown spots. This is there. Bacterial blights. These are the diseases are there, that symptoms are there, and we can have. So to make the CNN model and the study, we have downloaded the data from the Kaggle. Kaggle is one of the source of data. So Nair sir in the first session explained there are the different websites are available to download the data. So Kaggle is one of the data. And what is the data set available in my particular image classifications are nothing but I have divided my total data set into the training and testing data. So 1, 2, 3, 4, 5 classes will be at the output of my CNN. That is a multi-class CNN is going to train as well as the recognition. I will build the model for the multi-class. So how many classes are there? 5 classes are there. And each training data sets for each class, this number of images are available in my data sets. So total images for training is 3,984 images are there. For the testing, still there are the 5 classes are there. And for the testing my model, I'm going to use the 1,114 images. There might be question in your mind, sir, how to segregate these images in the training and testing? That is based on normally that is a thumb rule, 70% training and the 30% testings are there. There are some methods are there. K-fold technique is also there. That can be used the iteration in the images or the randomly they can fold randomly they can select the images from the training sample itself for the testing and trainings. So different concepts are there. Different researchers are work on this particular selection of the training data set and testing data sets. We can use the different research algorithms and on the basis of do the experimentation and try to see how the results are changing with respect to that. So this is my data set. Now data set is collected in which location, from which location. So I'm proud of that. One of the researcher from the Karnataka locations, they have collected this all database and uploaded on the Kaggle. That is a website. And it is a recent database for the 2023 databases is there. So database is one of the important aspect in the image that is in terms of the what we can say research. If you got the correct database, then your research is going for the correct directions. Otherwise, create some problem for the training the models, getting the results. So as we know, this is your networks or schematics is there. Now, based on this, so please tilt your head that is towards the 90-degree and try to understand how this model is there. So as we know, we can have the 16 layers in this CNN network, 16 layers. Input image layer, that is input layer, convolution layer, ReLU layer. What is a ReLU once again? That is activation function, pooling layer. So this is a combination of four particular parts are present. That is input image, convolution layer, ReLU activation. ReLU is once again that is a activation function. Pooling layer is there. Then convolution layer, ReLU layer, pooling layer, convolution layer. This is once again three second that is a convolution networks. Third one that is a convolution, ReLU, pooling. So three neural networks convolution layers are used. 3 convolution layers are used. 1, 2, and 3. 3 activation functions are there respectively for each convolution networks. After that, once we got this particular output of 3 layers is applied to the pooling layers, which will be converted that is in terms of the one dimensional. Then dropout layers, fully connected layers for after this all these things. Softmax function is activation function is used here, and there is a classification layers is at the output layers. So total 16 layers will be used in this particular implementation. I will show the results. Now, what are the evaluation metrics on which basis we can say my results of the algorithm is performing good or bad? This is nothing but the accuracy. And this accuracy, precision, recall, and the F1 score, these are the 4 performance parameters can be used to evaluate the performance of your networks. Now, what is accuracy? Accuracy is the ratio of correct prediction and the total number of data sample or the total prediction made by the classifiers. Now, TN and TP. What is a TN? TN stands for true negative. TP stands for true positive. What is meaning of true positive? True positive means the expected class for that particular input is a positive. And our algorithm or our model is also predicting the positive, means results is a positive, expected result was positive, and my classifier or my model is also predicting positive, is nothing but true positive. Now, what is the meaning of true negative? True negative is nothing but my input or the label data is a positive. Positive means the brain tumor is available. It is a presenting the yes, but my model is predicting the no. That is nothing but the true negative. Now, what is a false negative? In the my particular input data, whatever available data, label data is a negative. This particular image don't have the brain tumor. Brain tumor is not there. And my expected outcome of that model is also predicted. My testing of the model is also predicting, yes, there is no brain tumor for this particular image. So that is called as a false negative. So I realize the what is meaning of true negative and true positive, false negative and false positive. So this particular concept is used in the your part of the calculation in the accuracy. Then we can go for the confusion matrix. One of the confusion matrix is there. So what in my confusion matrix? Confusion matrix is nothing but your model, your algorithm, your machine or your CNN algorithm is going to confuse. How much it is confused? Confusion should be minimum. As a confusion minimum, accuracy is maximum. So it should not be confused. Second thing is a precision. Precision is a proportion of predicted positive that are correct and is given by the sensor TP upon TP plus FP, and all these things are there. So the F1 square, sensitivity, precision and accuracy, these are the performance metrics we have to use in the analysis of my algorithm. Just now I use the one word, the confusion matrix. This is called as a confusion matrix. What is a confusion matrix? So in the y-axis, I am having the true. True means the result of whatever the database which is available with me. This is a true. And what is in the x-axis? It is called as a predicted. This is the prediction of my algorithm. What do you understand from this confusion matrix? From this confusion matrix, I realize that for this healthy, how many healthy images are available on my database? As we know, these are the healthy images. How many total images are available in the healthy? So I can say that 270 plus 1, 271 plus 6. 277 images are available in my database and all are healthy, which is there in my database. Out of that, what is my algorithm or what is my model is predicting? My model has been predicted that 270 images out of 277 are correctly classified. This is called as a 2P. 2P means true positive. True positive. Out of that 277, one may be one is classified as a bacterial blight. 6 are classified into the alternaria. This is one more disease. So 7 images are misclassified. Out of that 277, this is meaning of the confusion matrix. Same thing we apply here. So 110 plus 3, that is a 113 plus 8. This is a 221. 221 images are there in the second diseases. Out of that, 110 images are correctly classified. Remaining 11 images are misclassified. So this misclassification should be as minimal as possible. Your algorithm, your model should be not confused. And this is a confusion matrix that I can plot the confusion matrix through the algorithm also, and I can predict the results. So this confusion matrix are playing the important role. One more experimental results we can show, that is nothing but the ROC curve. And the ROC curves are also representing the false positive rate and the true positive rate. That is also going to, what is the rate? What is the rate of the correct classification, what is the rate of the false classification, that is representing here. That is one more performance parameters are there. So I will not make any conclusion at this instant. So this is related to my experimentations, case studies. Now, as I told in my particular things, so I have explained the case study for the CNN. I can explain the case study of the ENN through the directly my experimentations. So let us will go for the experimentations, how the experimentations can be done. Okay, so I will show the experimentations. Are you able to see the my next screen? Am I right?
Yes,
Yes,
sir.
sir.
Yeah. So I'm going to show the ENN applications in terms of the experimentations. So this is a Google Colab. This particular implementation is done on the Google Colab. Are you able to see the Google Colab? This is a Google Colab ENN diabetes. So we have to predict whether that particular person is having the diabetes or not. This diabetes data is extracted or it is that is downloaded from the Kaggle websites. So this is important libraries will be imported first. Then these are the some files. Those who know the Python programming, they can realize this. So import the num as a np, import the matplot, that is for the plotting the plots, pandas as a pd. So there is a significance of each and every imports that we can learn later on. This is a part of the Python programming. Then import the data sets. So we can see here content diabetes.csv. So this content diabetes.csv is a file which is available in my data set, sample data set. It is available. So we have to upload now to perform that complete task. It will take much more time. So I will show the results. So content diabetes.csv is one of the file. Diabetes.csv file is on my system that is uploaded on the this particular program, that is for ENN diabetes. Dataset header is there. So what is the consisting these data sets? We can see the data sets. So how many rows and how many columns are there? There are the 9 columns. If you see, upload the data set and run the data set, so we'll get the contents of the data set. So how many data sets are there? 768 sample data sets are available in this particular diabetes data sets. 768 person ka data available hai. That's why. Then what are the features of the data sets? Features are nothing. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 columns are there. We can see the 1 to 9 columns are there. What is the output of this column is nothing but 1 or 0. So diabetes, yes or no. If it is yes, then 1. If it is no, then 0. So this is a label data. Why it is called label? Label means what? We know in advance whether that person, that is a serial number 0 person, serial number or database number 0 person having the diabetes, yes or no? Yes. But on which basis this diabetes is available? On the basis of this feature. Features are, what is the features? These are the features which are there. 1, 2, 3, all features are there, and we are getting these results. So what I should do now, next step is I have to find out which is a dependent parameter and which is an independent parameter. So what is the meaning of dependent and independent? Dependent means this output depends upon the all remaining the 8 features. Which are the 8 features? Pregnancies, glucose, blood pressure, skin thickness, insulin, BMI, diabetes, prestigious functions, age. All these are the features. All these are the independent parameters. Output of this output means whether this diabetes person or non-diabetic person is based on these different features. So 8 is my features and 1 is my outcome. Outcome is a dependent features, and what are the basic features, which are these are the independent features. So we have to classify it into the dependent and independent. So there will be matrix will be extracted as a dependent features and the independent feature. So we divide the dependent features and independent feature. So X is one of the, what we can say, the array, And this X array will be consist the data set ILOS function. So what is ILOS function? ILOC function is used this function to extract the features which is want here and to eliminate the things which is not there. So 0 to 8. So what you understood now? The whatever the last row that is output is eliminated in this particular 0 to 8. So that will keep the all 0 to 8 rows, columns of that given database, and it will be eliminate the last one column. So we'll get the these are the independent feature. X is a independent feature. Now what is the once again Y? Y is a dependent feature. So we'll get the Y is a dependent. So we extracted the input data from that input data. What we can say the dependent features and the independent features. X is my independent features and Y is a dependent features. Splitting the data set into the training set and the testing set. So we are using the sklearner libraries in between that. And in this particular sklearner library, xtrain, xtest, ystest is a function is there. And we are written here, test is equal to 0.02. What is meaning of this? Means 20% of the data is used. How many samples are there? How many data samples are there? There are the 68 samples are there. Out of 68 samples, 20% of samples are restricted or used for the testing, and remaining 80% samples will be used for the training. So dividing the testing and training samples will be done there. From the sklearner libraries, we have to make the standard scaler. So this is a pre-processing of that particular data is there. Data cleaning, data pre-processing will be done in this particular transformations. Then further, we have to use the Keras libraries, model sequential, dense, then Renu and dropout layer. These are the essential libraries we require to build the ANN model. So initializing the ANN architecture, what is a concept we are using? The sequential concept classifier is a sequential classifier used. That is a forward propagations. Adding the input layer. So what is the input layer? Classifiers. Dense input layer is a 12 input layer. First classifier that is a input layer. So kernel initialization is that HV high uniform is used. Activation function is a sigmoid function is there, and all these things are there. So classifiers are going to initialize the ANN. After initializing the ANN, we can go for the compiling the ANN. So compiler the ANN optimizer is used as an Adam optimizer. There are the different types of the optimizers are there. Loss function is nothing but using the binary cross entropy. Binary cross entropy is calculated there, and the accuracy is going to calculate for the different database. Then we are fitting the ANN and train the model. So we can, after training the models, we are going for the different epochs. So epochs is defined as 100 in this case. So how the epochs are there that we can understand. Epochs are 100 based on the number of samples, the input database, batch size, and the epochs are going to calculate. So for 100 epochs, your this per 100 epochs, your in particular what we can say the system iterations are going to perform. So how many iterations are performed? There is a 42 iterations for each there. So there are some mathematical concept to calculate the iteration. All these things, sir. All 100 iterations are compiled, and we'll get the final classification accuracy. After that, we can understand what is the relation between the epochs. How many epochs is sufficient for my training and testing? So number of epochs, and we can get the accuracy for the training accuracy, testing accuracy. This graph will be represented, and I can realize if I increase the number of epochs around 50, which is more than sufficient for getting my results. So this data is available in terms of the tabular or the Excel data. It will not take much more time for the calculation. Otherwise, if it is image-based data, 2 data is required. Otherwise, we have to add the GPU for the processing this. Further, we have the particular loss functions are there. Then you can calculate the model loss based on your training and testing. So what is a loss, train loss and test loss? Then I can predict any data which is there. So known data are there. I can predict the unknown data are there. So if you give the unknown data which is not there in the database, that can be also predicted based on the our learning rate. So out of 768, 20% are the training and the 80% are testing. So instead of this existing data, if you are given the another data which is not known to my model, that I can apply as a input data, and I can predict whether that person is having the diabetes or not. Such things are available. So if you want to learn, what is time now? This is a 4:44. So if you want to learn that model, I can show the learning also. Because I have to show the one more thing here. So it is showing the error here. Why? Because the data is not uploaded. So I have to see the where is data exactly my data. Upload the data. Where is the data? So data is in my folder. Database. Which database I have to use? Diabetes. So you can see here the diabetes data is available. I have to copy this folder, copy the path, and put in this particular location. Then we running. Yes, we are getting the all data. Then we can find out the dependent and independent. Yes, we got the dependent and independent. Then again the Y values will be calculated. Then splitting the learning, training and testing. Yes, it is a train classified. Then it is a standardized scaling. Importing the libraries for the SK learner. Keras library for the building the ANN model. Then further, we can go compile the model and execution will be starting. See the your model is learning now. See the model is learning now. Model is learning for 100 epochs. Are you able to see the model is learning?
Yes, sir.
Yes. Then it will calculate the epochs versus the results. Once again, results will getting same because the input data is same. I'm going to show the demonstration to you. The data is changed. This particular application can be used for the any branch. It is not for the computer IT or the anybody can use this application. Prediction of the market, MBA, MCA, then finance. We can go for the robotics applications and anything we can predict. Prediction can be done. So this then confusion matrix is developed here once again. This is a confusion matrix, true positive, true negative. Then we can get the calculate the accuracy, also calculate the overall accuracy of the model, overall accuracy, testing accuracy and training accuracy you can calculate. And like this, I can have this particular results. So researchers, those who want to work in this particular ANN field, sorry, this machine learning, those are not having the background of the what we can say the computer IT, NTC or the computer related background. Civil engineering, mechanical engineering, electrical engineering, they can apply this particular artificial neural networks, that is ENN model, on their existing environmental data or the any other data in their fields, and they can implement these things in their particular research also. So I have shown the first case study and the working model for the ANN. So now I will show the second one, that is for the pomegranate. So just now I have worked on that little bit. before to show that, I will show the database and then we'll show the detailed model, how it will be working. So pomegranate disease. So we can see these are the 1, 2, 3, 4, 5. These are the 5 folders are there. And these are the training images, and the test images is having the 5 folders. So we can see this is one of the folder. If I up these are the images are there. These are the different images are there, which goes for the first disease alternaria. This is one of the disease, and these are the sample images is for that particular disease. So like that, we have the different images for the different disease. Now this is a once again the part of the CNN. Now I'm going to show you the image classification, that is a approved disease classification based on the CNN application. And for the CNN, this is the image classification is there. And how many classes are there? There are the 5 classes are there. 4 disease and 1 is healthy. Any fruit which is coming in front of that particular data, any fruits image is coming for this model, that can be predicted either for disease or the healthy fruit. So that classification is going to take place. So to run this particular CNN algorithm, we have the pip. We have to install the pip. Pip is one of the TensorFlow function that is in the OpenCV Python, and that installation is essential. That once it is installed, then it will be executed. So these are the some files, what you can say libraries we have to import toward this particular applications. Then this is a check the image size. So we have to check the image size. So inbuilt functions programs you can write what is the size of image. So I will not able to execute this particular program because it takes around 5 to 6 hours to get the results, final results, because it's image classifications and time complexity of this particular program is particular implementation is very high. So if you run this, then what is output of this image? My image size is 3120 into 3120 pixels. Size are there, length and width of that particular image in terms of pixels. Then height of the image height, image width, and how many batch size. Batch size is playing the important role into the CNN. I have recently mentioned in the 20 epochs, but I don't know how much I have did 10. I reduced the epochs, number of epochs, and that will be iterations later on. Then I have uploaded the drive. So my images are available in the drive. So this complete drive I have to upload on my Google Colabs. So drive mounting will be done through this program, this particular 2 functions. Once the drive is mounted, we'll get the results. Yes, drive is mounted. We are going to, from that drive, we are loading the images, train images, test images will be loaded there. Then loading the training data sets. After that, we have to load the training data sets. How many data sets are found for the training? 3,984 images with the classifying the 5 different classes, including the 4 that is disease and 1 healthy. These 5 classes with the 3,984 images are used for the training of this particular algorithm. For testing, 1,114 images are used for the testing of image, testing of this particular algorithm. And this particular testing folder consists the 5 classes, and these are the class. Train the datagram, we have to generate the image generators. So this is once again image processing, that is a rescaling, rotation, invariants, and all these things will be done for the data generation or the data we have to generate from the training samples. After that, we'll generate the train generators. We have to resize the image. Once again, 3120 to the 3120 image has been resized into the small size because the computational complexity we want to reduces. The class modes are categorical models. If it is more than 1 class, we have to write their category. If it is not less than only 2 categories, then we can say the binary categories are there. Subset are training. Shuffling is there. I can shuffle the images for the training purpose. For the validation purpose or the testing purpose, I have to get the once again what is the size of image and everything. Shuffling is not doing for the testings. Only shuffling is done in the training. So we find the images. We are starting to build the CNN model. So first convolution layer, second convolution layer, and third convolution layer. We realize remember how many convolution layers are there. So these are the 3 convolution layers are used in our that particular architecture of model. So each convolution layer is consisting the activation function and pooling layer. Activation function, pooling layer, activation function, pooling layers are used. ReLU's activation function is used here. We can use the softmax also. That the output layer we use the softmax, but the remaining 3 layers we use the ReLU's functions. Flatrun layer is used. Flatrun layer is used for the converging the 3D tensor to the 1D tensor model. That is Flatrun layer is used. Not pooling layer. Flatrun layer is used. Then further we have compiled the model. Then train the model. That for each epochs model has been trained. So although we have mentioned there are 20 epochs, but it is trained for the only 10 epochs because it is getting the so much time for the final results. So after the these epochs are run, accuracy, that is a training accuracy, training loss, testing accuracy, testing loss, this value accuracy are generated here for that training model. Then we have to evaluate the testing accuracy finally, that testing loss and testing accuracy. Then afterwards we can have the what we can say the predictions are there. After making the predictions, we have the plotting the classification accuracies there. We have to plot the confusion matrix. In the plotting the confusion matrix, this is your confusion matrix is generated. This is a confusion matrix is generated, and this can be plotted with this figure. Just I have shown in the results of my case studies. This is a confusion matrix. So we can implement such a different classification algorithms in the different levels. So such a things can be done in the particular classification algorithms. So I think I'm near to the ending of my session's time. So this is from my side. I try to do explain everything. So once again, thank you very much. So over to the particular what we can say the all of you. So thanks to all for the patient listenings, and I try with my best whatever I learn. Still I'm learning, and that will be useful for all the communities which are there in the engineering fraternities, whether it is a technical, non-technical persons. But these CNN, ANN applications can be implemented in many research, and we can publish the papers. It is a real-time applications can be implemented. So which is a need of the market now, artificial intelligence and machine learning. Over to you, madam. I will be very happy to make the interaction to all of you. If you have any questions, you are free to ask me. Yes.
Hello.
Any
Yes, sir.
questions?
Hello.
Yes, sir. Yes, sir. Please.
Sir, you told that before training the data set, there is a shuffling up in training data, but there is
Yeah.
no shuffling of testing data. Then whether it will match the training with the training and testing data?
Sir, what happens there? Already we have divided the data set into the training and testing part. Are you getting my point, sir? Number of data in the training is different. Number of data in the testing is different.
But there is dependent and independent data is there. If you are shuffling these independent data, then dependent data should be also shuffled. No?
That is thing, na, sir. If you don't shuffle, then algorithm has to be recognized properly.
Okay.
See what I'm going to discuss with you. I have the images of the training. I have trained the algorithm.
Okay.
But any unwanted image or unknown image is given to that particular algorithm. Algorithm has to be predicted correctly.
Okay, right.
Yeah. So we are making the shuffling means we are confusing algorithm. If it is confused, still it has to be correct the classification.
Right, right, sir.
Yes, sir. Please, anybody? And there are the k-fold methods are there. K-fold method is there using the ANN, sir. You will read the k-fold techniques or methods. How this k-fold techniques method is used for the shuffling of data. And it is basically shuffling is used in the ANN more because it's a tabular data. For the shuffling in the CNN, it becomes little bit complex. But you implemented here in the shuffling concept.
Okay, thank you.
Yes, sir.
Hello, sir.
Yes, sir.
In one of your slide while explaining neural network, you written one network diagram, and aside to that, there are drop-down neurons.
Yeah.
So, what is basis of that drop-down, and how you done that?
Sir, it is randomly dropping. The weight functions which are not playing the important role to reduce the error. That will be the randomly dropping.
So that software itself is doing.
Software itself is doing randomly. That you have to put the how much amount of you have to drop. That you have to mention in your program.
Okay, sir. Okay. Okay, sir.
That is inbuilt functions are available. That you have to mention how much dropping rate has to be there. 0.1,
Okay.
0.2, 0.3. That you have to mention.
Okay, sir. Thank you, sir.
And this is once again, sir, experimentations. If I do the 0.1 dropping, then what is my results? 0.2 dropping, what is my results? What is the time complexity? What is the space complexity? What is the accuracy? What is the loss? That you can make the experimentation results and that you can put in your papers.
Yes, sir. Yes.
And that you can make your own observation. If I make the dropout layers this much, what happens? What will the effect on my model and the accuracy?
Okay, sir.
Yeah. There is one more that is a hypertuning parameters. It is called as a learning rate, sir. I told the value of this learning rate is a 0 to 1. If I put the 0, then what happens? If I put the maximum, what happens? That is a gradient descent is one concept used. If you make the maximum value of the learning rate, the never local minimum will be optimized. So algorithm will not, or your model will not be learned properly. Will not get the probability of the error is a minimum. It will not showing the minimum error. And if you select the very less value of the learning rate, it will take so much time to learn the model. So optimization is required there. So either I have to keep the minimum or maximum. It comes from some explanations by implementation itself.
Okay, so it is purely experience based.
Yeah,
Means,
yeah. It is purely experience. It is based on your input data, sir, also. On which application you are implementing this ANN CNN model.
Yes, sir. Yes, sir. Thank you, sir. Okay.
Anything more?
Any question from the participant? I think
Will we be very much happy to help you in future also regarding the faculty members. Those are not having the background of this IT computer. Will have the very much eager to interact with you, and whatever your problems in the mechanical, civil, or other branches, we can have the support for the implementation. All these things. Our team of the faculty members is also working on this particular aspect. So we'll be very happy to interact and collaborative research.
Thank you, sir.
Yeah.
I think no more question from the participant. So it's time to deliver the vote of thank. On the behalf of ENTC department, it is my privilege to deliver the vote of thanks to Dr. Bhagvat Jadhav sir. Thank you, sir, for giving your valuable time to share your wealth of knowledge and expertise with us. The practical The practical examples, case studies, and innovative approaches you shared have sparked the new ideas and direction for all of us. With your permission, I conclude the session 12 is over, and I would like to take the moment to thank all the participants for their active involvement. And I request all the participants to stay in the same meeting for the next session 13. Thank you, sir.
Yeah. Thank you very much.